Hello everyone, you're welcome to my class today. And in today's class, what we are going to be looking at is the sum of an arithmetic progression, meaning how to sum an arithmetic progression. Okay, I implore you to be there, as this class you're going to get a lot from it. I remain Victor Odigoma here once again. All right, the sum of an AP, that is arithmetic progression. All right. Um, this should be our class 10. Yes, in arithmetic progression. So if you've not been in the other classes, please you check out what we did in those classes. Now we have in the previous classes been able to get some understanding. That understanding is that we have seen how we can possibly be able to represent an arithmetic progression. That is something of this nature. We have been able to say that an arithmetic progression is any sequence whose terms goes by addition, constant addition of a particular constant. Okay, that constant is constantly added to term to get another term, and so it continues. That's to say, if we have a to be the first term, then if we add the common difference, which is a constant across either positive or negative, then the second term will be a plus that common difference, and the third term will be a plus 2 times the common difference. The fourth term will be a plus 3 times the common difference, and this will continue until we will get down to the last term in that sequence if there is, which is a plus in bracket n minus 1 then times the common difference. So this is a typical representative of an arithmetic progression. And when we say let Sn be the sum of this AP, okay, let this symbol represent summing this AP, that means we are saying that Sn is equals to the first term plus the second term a plus d plus the third term, which is a plus 2d, plus we will continue to add until where it stops or where we choose to stop, a plus bracket n minus 1d. Okay, that's the meaning of this. Now this expression has been simplified to generate Sn equals to n over 2 in bracket 2a plus in bracket n minus 1, the common difference, or we either use this to finding the sum of a given number of arithmetic progression, or we use this Sn equals to n over 2 in bracket a plus the last term. Okay, in this is expression 1 and this is expression 2. This expression 1 is commonly used, but this expression 2, we use it when the first term and the last term is made available in that question. We can use this. So we use either of this. Let me take you through an illustration, an example of what I'm talking about here. If you have something like, say, given let's say 2 comma 5 comma, yeah, the gap here is 3. So the gap, if I add 3 again, to give me 8. And this 3 is enough. But let me just add another 3 here to give me 11. And this thing continues. This is an arithmetic progression. Okay? And the first we have is the first 4. The first 4 is what we have. Assuming the question asks you find the sum of the first 20 terms. What does that mean? This simply means you are being requested to find the value, what it will give you when you add 2 plus 5 plus 8 plus 11 plus what will be next, plus what will be next, plus what will be next, until you get to 28th term. Do you get the meaning of this? That's what it means. You are being requested to find that summation. I know it's going to be tasky. It's going to be a very big task for you to say, as soon as you've been able to know this, you add 3, get what is next, add it, 3 again, get what is. Of course, if we put this into a computer will just do it at once. We may not need to, just even in Microsoft Excel, you can plug in some information here, ask the computer to generate. It will generate the values for you and do even the summation. But right now, we are teaching it on a literal, to get a literal understanding of what is going on there. All right. So, getting the sum of the first 20 simply means adding what is here plus here plus here plus here until you keep on going until you get to the 20th term. I think that explanation is good enough. Let me use my expression here. Of course, one can also configure this in a system. The system will carry out the activity. All right. So I'm talking about find the sum of the first 20th terms. Okay. You say using solution using Sn equals to n over 2, 2a plus in bracket n minus 1, common difference. Here, n is 20, comma, a is 2, comma, the common difference is 3. What again do we have there? Nothing. So we look for S20. That will give us 20 over 2 into 2 times 2 plus 20 minus 1, common difference 3. Yeah. So here we have 10 into 4 plus 19 times 3. And 19 times 3, 19 times 3, 57. So we have 10 into 4 plus 57. 4 plus 57. 4 plus 57 is 61. So we have 10 times 61. Okay. 10 times 61. 10 times 61, that will be 610. So do you see that if you keep adding this thing one after the other until you get to what is in term 20, you will get 610. You get 610. That will be the sum of the first 28 terms. So I am sure that this explanation is good enough to explain to us what we mean by summing an arithmetic progression. I trust God that there is no information leaving behind. Okay, take a look at it. Take a look at it. This is the explanation. Thank you so much for being part of the class. I remain Victor. God bless you.